Okay, welcome back to Unit 5, Lesson 2. On Lesson 1, we looked at irrational numbers. Irrational numbers could not be written as a fraction. Rational numbers can be written as a fraction. Then we had Lesson 2, and we're talking about volume in Lesson 2 of circular figures. So what are the circular figures? They are your cylinder. A cylinder looks like this. It's looks like a can, like a soda can, and it's got a height. Let me highlight this. Every cylinder has a height, h, and it has a radius, or r. And we have this volume equation, and the volume is the base times the height. Now we see this also in the prism, where you have a base. The base is the length and the width. You don't necessarily have to label this as L and W. It has a lot of different sides. You have a top base, you have the right side, you have the front. So right now we have the front as the base as the front. But you might want to make the base something else. So let's say the length was 3 and the width was equal to 2 and the height was equal to 5. In that case, you would have, if you're using the 2 and the 3, you'd have volume equals 6 times 5. But let's say you wanted to make a different volume with the base times the height. Well, let's say you wanted to use the right side. That would be 2 times 5 times 3. So in that case, the volume would be, if you're using the right side as the base, that would be 10 times 3. And then you could also do, maybe you use the top. That's 5 by 3 times 2. And that volume would be 15 times 2. But they all equal 30, notice that. So in the prism, you have a lot of flexibility. Not so much in the cylinder. In the cylinder, you have to find the circular bases for the radius, and then the height is determined that way. So be careful what you're calling the height when you get to the composite figures. That leads us to the volume of a composite solid. So here, be careful. I could call this the height and the length and the width, or I could call it something else, and that could become interesting. Let's say I use, well, let's start with what a composite solid actually is. So let's get our highlighter out here. Volume of a composite solid. So the composite solid, it's right here, made up of more than one type of solid. Okay, now this figure here, if you look at it, has two pieces. It's got the prism. It's got an entire rectangular prism, and we'll call this usually we call the smallest thing the width, the second is the length, and then the longest is the height here in this situation. So we have the front base 30 times 25. So the volume total is what we'll call the composite. It's made up of this prism, the volume of the prism. And now you have a cylinder sitting on top. But it's not it's not a whole cylinder, it's just a half a cylinder. And the cylinder has a radius halfway across of half of 25. So you could use the radius is equal to either 25 over 2, or for those of you like decimals, 12.5. And make sure you use your centimeters here. So we'll keep this as the height of the cylinder. It's 50. But we don't have a whole cylinder. We only have half of a cylinder. So we're going to multiply times 1/2. Be really careful. So when you're working with volumes, you're going to have to do a lot of, you have a lot of things in the numerator and the denominator. So you want to make sure you multiply numerator numbers with other numerator numbers, and then at the end, make sure you multiply all the denominator numbers and then just wait till the end, divide at the end. That'll kind of avoid any mistakes. So we have the volume total, which is going to be, we'll call it VT. The volume of the prism is length times width times height. That's the base times the height. And this one's also, let's use a parentheses, and then we'll do pi r squared h. That's the volume for a cylinder. And we got to multiply it times a half. So some of it's just plugging in. Length is 30. This one's easy because it's all integers. But you get a little trouble over here. Remember we talked about keeping numbers, multiplying the numbers in the numerator? Okay, well we'll use 25 over 2 and we'll explore it. So we have pi. Okay, well let's switch this to a bracket because we're going to need a parentheses. We like to do different grouping symbols, so we'll change this to a parentheses and we'll use 25 over 2 squared, okay, times the height, which is 50 in the bracket. Okay, we have something called Pemdas that tells us to do exponent first. So I'm going to go VT. I'm not going to multiply this yet. I'm going to leave the 1/2 out there because I'm going to do the 25 over 2 first. I'm going to do them separately. I'm going to square 25. So I'm going to clear my calculator and I'm going to type in 25 and I'm going to hit squared. And that gives me 25 times 25 is 625 over, and I'll do 2 squared, which is super easy. You can't mess that one up. It's 4 times 50. Okay, so now I'm getting closer to the end. Volume total, I'll do all this multiplication. Since it's separated with an operation of addition over here, then I know to keep this separate to do all this multiplication first. So I'm going to something on this calculator. 30 times 25 times 50, straight multiplication, 37,500. Okay, now here, numerator, 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 numerator. In the denominator is the 2 and the 4, so we can just go ahead and put this here. 2 times 4 is 8. So we've done the denominator multiplication. We just need 625 times 50. 625 times 50 is 31,250 pi. So I want to leave it in terms of pi as long as possible. Now at this point, I need to get a decimal answer. So I'm going to go with total volume 37,500, and I have my 31,250. I'm going to multiply that times pi, or 3.14, and then I'm going to divide that by 8, and I want to round it to the nearest tenth, I believe. The nearest tenth is going to be here. So the number that follows the 8 is a 4. We're going to round it down. 12,271.8. And now I'm going to add my 37,500. And I get 49,771.8. I'm almost done. I have to give my units. And what is the units? Here, there's centimeters, and there's 3 dimensions to this. 1 dimension, 2 dimensions, 3 dimensions, so that's why it's cubed. It's a volume. So that's volume of a composite solid. Okay. We looked at cones that they are 1/3 the size, or the 1/3 the volume of a cylinder. So their equation is the same exact thing as the cylinder. Remember, the cylinder would be much bigger. Cover it like this. You could fit 3 cones inside of a cylinder. So if you ever, so anyway, we just take the volume of the cylinder times 1/3. Again, don't mess it up. When you multiply at the end, multiply numerator numbers together, and then finally the denominator number. So you have a volume of a composite solid. We have the volume of a cylinder. So V total is going to equal the volume of the cylinder, which is this thing. This has a height of the cylinder. Then we have a cone here, the volume of the cone, and it has a height of a cone. It has a different height, so be careful. The H of the cone, they both have the same radius. Be very careful there too, because you're given the diameter, so the radius is going to be half of that, 5 centimeters for the radius. And we'll just label it on both. So we end up with the volume total. Now the cylinder is pi r squared h, and then the cone is 1/3 pi r squared h. They're identical except for the fact that the cone is 1/3 the size. So if you were to fill up, you know, a cone that had the same radius and height, you could fill 3 cylinders with that. Anyway, make sure you plug in the right numbers. Pi, the radius of the cylinder is 5. Okay, you can't mess that up. 5 squared times the height of the cylinder. The height on the cylinder is 3. Plus 1/3 pi times 5 squared. I like using parentheses. And then the height of the cone is actually 4. So we get 5 squared is 25. Pi times 25 times 3, which is 75 pi. Here we have 1/3 times pi times 25 times 4. Okay, we're going to do all this numerator stuff. 25 times 4 times pi is 100 pi over 3. Now at this point I could get the decimal answer, but I want to find my answer in terms of pi because it's much cleaner of an answer. So I'm going to get a common denominator here. I want to change 75 to something in thirds. So if I multiply 75 times 3, I get 225. So I could change this number to 225 pi over 3 plus 100 pi over 3. Common denominator, yes. Common denominator means that I can put both answers over 3, and then I add the numerator, so I get 325 pi over 3. That's the best answer. But they also want you to give it in terms of pi, so I'm going to go ahead and do 325 times pi. This calculator gives it in terms of pi. As long as it does it, when I divide it by 3, I'm going to get 340 point, and then to the nearest tenth. 3 and then a 3, so I'm going to keep it at 340.3. And it's in centimeters, so I'm going to give it in cubic centimeters so that my answer is in the correct units. Okay, good luck.